everybody, and welcome to our Talking RV Tech. Today we have our panelists with us. Let's get everybody up here involved in it. We're going to talk about the house batteries. They're the lifeblood of your RV. They not only run the 12-volt systems that you're familiar with, but they are also going to be powering up AC units, 120-volt units. They will also work with your propane system. So it's very important. There's a lot of problems with batteries, lead acid batteries, especially out in the market. They last 2 to 3 years. They should last much longer. So let's talk about the panel we've brought in. We've got Fred Weyemeyer from Fred is from US Batteries, and he has over 50 years of experience with lead acid batteries. And a wealth of information. And I ran into this company years ago at the California show. Very impressed with them. So Fred's going to talk batteries, construction. I'll have Dennis Wieske. Dennis is from Progressive Dynamics, and he's been with them for 6 years, but he's had over 12 years of experience in automotive safety and so forth. And then we've got Dustin Simpson, is owner of California RV Specialists. And he actually does hands-on service work, and he sees this thing happening every single day. We got Chuck Woodbury is in the background and backstage, so to speak, and he calls himself the canary in the mine shaft. So if it gets too technical, Chuck's going to jump in and go, what? And then I'm Dave Solberg. I'm your host. I've been in the industry since 1983 and spent 5 years on the road traveling, training dealers, and I had my share of battery issues. So the first thing we're going to do is we're going to bring up Fred, and we'll have Fred we would like to talk about the different types of batteries that are available. I think I've got the wrong slide up here, so I am going to pull that off and go to the house battery section. I got to tell you, we are this is our first run at it, and so we're doing a little bit of graphic design here. There it is, deep cycle batteries. Let's make sure I get the right one in here, add it to the stream, and go back to the first section. We do have a couple ground rules that I did want to point out as well. We will be taking questions, but I would ask that you make the questions brief, and if it pertains to a certain make or model or year, and also keep in mind of what we're going to do. We're first going to start about batteries, what they do, how they're made, quality batteries. The second thing is proper charging the batteries, and then we'll open it up for questions and answers. So if it doesn't pertain to those first two, then let's wait until we get into the open forum of that. So with that, we'll start with Fred, and just kind of what are the different types of batteries, manufacturing, and I'm going to open it up to you, and you've got about 10 minutes, and then we'll grab some questions.
Excellent, David. Thank you for the nice intro. Can you bring up the slide with the cutaway battery?
Yes, I can. Let me
jump right into that. We are here today to talk about house batteries, which implies that they are the batteries that are used to supply the auxiliary loads, but not necessarily supply the cranking requirements for engine start. And it's important to understand that there are some pretty major differences today between automotive SLI, which stands for starting, lighting, and ignition, and that's your typical automotive batteries that you would use in your car. Can be larger, obviously, in a large motorhome or something. But the house batteries are a completely different design. If you were to open an automotive battery, you would see probably expanded grids, envelope separators, typical automotive battery construction. If you open a deep cycle battery, you're not going to see any of those characteristics. It's going to look more like a battery from 30, 40 years ago, which you might have found in your old 57 Ford or something. The major difference there is we still use what's called antimony alloys. The automotive batteries used to use antimony in the grids, but because antimony contributes to water loss, we embarked on programs to remove antimony to try to make the batteries maintenance free so that you didn't have to add water during the life of the battery, which then leads into the fact that deep cycle batteries still require water addition. And that's because we use a relatively high antimony content in both the positive and the negative grids. And that's basically there to impart a high cycle life, which is a requirement of your house batteries. Nobody wants a battery that's going to cycle 20 or 30 times, and then you would have to replace it, which would be the case if you did that with modern maintenance-free automotive batteries. Beyond that, you'll also see some major construction differences. You're going to see very thick plates, both on the positive and negative electrodes. You're going to see a leaf separator, which looks completely different from the separators in an automotive battery. The premium separators used in deep cycle batteries are made from a rubber compound, and that is purposely used to offset some of the effects of antimony for water loss. The premium rubber separators actually have components that help to reduce the amount of water that you have to add over the life of the battery. If we could go to the next slide, Dave, we'll talk a little bit about how that affects the operation of the battery.
Okay.
Deep cycle batteries do have slightly different performance characteristics. They have the desirable characteristics of long cycle life. A premium deep cycle battery should last 500 to 700 cycles if you discharge it completely on every discharge. Another characteristic is that if you manage the depth of discharge, you can get much longer cycle life. One of the downsides, though, of the chemistry of the battery is it requires a little bit higher voltage during charging. They can survive at the normal automotive voltage of on a 12-volt system, 14 to 14.5 volts, but it will increase the charge time. Our charging recommendation that you see there for a 3-stage charger actually suggests going up to 15 to 15.5 volts. If that causes problems with the some electrical systems, they can survive very well at 14.5 to 15 volts, but it will require longer charge times. We understand that most RV and marine type applications probably don't have a true 3-stage charger. This is our charging recommendation for most deep cycle applications. But we also do allow a 2-stage charger, which will be on the next slide, Dave, if you can pull that
okay.
up.
One thing before we go to the next one, I did get a question that came in that said, how long will it take to charge my battery if can I start my tow vehicle and charge it with the alternator for an hour?
So obviously, you'll get some charge in. We try to set up our charging regime so that if you discharge the battery completely and want to recharge it completely in one charge cycle, you should be able to do that within a 12-hour period. And that's for general deep cycle applications. Most of these batteries are used primarily in golf car and small electric vehicle applications where they don't necessarily have onboard charging like an RV or a motorhome might have. So we try to set up the charge regime so that you could fully recharge a completely discharged battery within 12 hours. If you don't have the 15 to 15.5 volt charger available, all that means it's going to take longer. So it may take 15 to 20 hours to achieve a full charge. But so far, we haven't been able to do that in 1 hour. You can get a significant amount of charge in because you can charge a battery at we basically follow the ampere hour rule. So you can charge it at a rate in amps that's equivalent to the number of amp hours remaining to be charged. So if you take 100 ampere hours out of a 200 ampere hour battery, you could theoretically charge it at 100 amps. Most people don't have that capability, but
Fred, for
amp charger is going to charge probably at a full 25 amps for an hour.
Fred, for our people that are watching right now, on your charge time grid, is that for one battery or multiple batteries?
It doesn't matter. That would be one cell, one battery, or a string of batteries, which could go all the way up to 120 volts. We have applications for stationary applications where you may have a string of 120 volts. So it's basically independent of the number of cells or the number of batteries. It's basically based on amp hours, so amps over hours.
And one clarification that with lead acid batteries in the RV industry, we typically are saying only draw them down 50%. Is that correct?
That is true. And
Okay.
that's kind of the next discussion about the application of deep cycle batteries.
Yeah. I just wanted to
Obviously,
say that because you had said if you draw them down completely, so but
that's
completely
exactly
means a
right.
50%. Okay.
So when we rate cycle life on our batteries, and our batteries are rated at 600 to 700 cycles at what we call an 80% depth of discharge. And that's based on the 20-hour capacity, which is a common rating system. We'll get into differences in rating deep cycle batteries versus automotive in a second. But that is true. If you take all the energy out of a battery every time you use it, you're going to get that requisite 600 to 700 cycles. However, if you have an application, and this is something we highly recommend, where you can manage depth of discharge, for example, if you cut that 80% in half to 40%, you would expect to get about twice the cycle life. Actually, you get a little interest on your investment there. You get an extra 15% if you do that. So that 600 to 700 cycles is more than doubled to over 1,500 cycles if you can keep your depth of discharge below 50%.
Okay. Next slide.
And that's what we're showing here. Want to talk a little bit about the effect of opportunity charging. And people say, well, you know, what do you mean by opportunity charging? Is that to take the place of regular charging? It's not. But if you can manage the depth of discharge through the use of opportunity charging, pays that significant benefit that I just went through. It more than doubles the cycle life. And obviously on that chart, it is a logarithmic chart. That's the reason it's not linear. And you'll see the scales there are exponential. But if you can manage the depth of discharge even below much less than 50%, you get a significant increase in the overall cycle life.
Okay.
It's important to understand, we talked a little bit about rating. So for automotive batteries, people are used to seeing the cold cranking amps, which is a measure of how well the battery will be able to crank an engine, particularly at low temperature. Deep cycle batteries are not designed for engine cranking, even though they certainly are very large batteries typically and can crank an engine very easily. We don't typically rate deep cycle batteries with a CCA. Some of the modern testers, the electronic type, they don't actually do put a load on the battery, but they measure the internal impedance, often require a CCA rating, which we don't have on our batteries. However, we do have a 20-hour rating, which is obviously a very low discharge rate for a long period of time, 20 hours. If you take that 20-hour rating in amp hours, for example, a 200 ampere hour battery, and multiply that by 3, that gives you a close approximation of the CCA number that you need for those two types of electronic testers.
Okay.
This is an interesting slide that I put together some years ago. People often ask, what is the best capacity rating to design my system around? Because obviously it's important not to deep discharge the batteries on every cycle, because you'll pay for it in reduction in cycle life. So what we always tell people to shoot for about 50%. That does a couple of things. Number one, it manages that depth of discharge, so you get the best optimization of the cost of the installation versus the cost of use, which is measured in the cost of the battery over its cycle life. And obviously, you know, people ask, well, how many batteries do I need to put in my application? Is one group 24 deep cycle battery enough, or do I need to put in 4 6-volt batteries? And obviously that's a measure of the cost. Obviously you're going to pay more for 4 6-volt batteries than you're going to pay for one small 12-volt. But you'll get much longer cycle life because you're going to be managing the depth of discharge. We suggest targeting, if you know what your loads are and about how long you're going to be running them on a daily basis, shoot for about 50%. That gives you the best optimization of initial cost versus life cycle cost.
Okay. We're going to we're gonna go to Dennis here in just a second. We're going a little longer, but I would like, Fred, if you could just give me a real brief description of quality of batteries. What do you look for, in your batteries, good batteries that are in the market versus something that might be on a membership box store battery?
Sure. So people often ask, should I put in a small 12-volt battery, or why would I put in 6-volt batteries? And that has a relationship with the quality of the battery. A lot of the Group 24, 27, and 31 batteries that are intended for engine start, or maybe they're even a hybrid, do give you some improvement over the cycle life of a typical automotive battery, but they're not a true deep cycle battery. So they're not going to cycle as long as a true deep cycle battery. US Battery makes obviously a lot of 6-volt batteries for the higher ampere hour capacities. But we also make a line of true 12-volt deep cycle RV marine batteries. And they are specifically designed just like any golf car or small EV battery type, with all the same quality and additives that we put in for deep cycle performance. So that's important to understand. The other reason that 12-volt batteries are available in smaller ampere hour capacities versus 6-volt batteries and larger ampere hour capacities is just basically weight. If you built a 12-volt battery at 200 ampere hours, it would be pretty heavy. It's going to be well over 100 pounds, and that's pretty hard to move in increments. So if you need to build capacity beyond 100 to 150 ampere hours, typically it's better to go to a 6-volt battery, even though we do make 6-volt batteries that have up to 400 ampere hours.
Okay.
But that battery weighs over 200 pounds, so you're not going to move it very easily.
No. All right. Well, we're going to go to Dennis now. We'll come back. We've got some more information on the batteries. I got some questions that'll help lead into that. But I wanted to get into Dennis's slides on charging. Again, he's with Progressive Dynamics. We actually just put in, what model was it, Fred? It was a 9160, or do you remember? In that Thor?
Now, was that for me?
That's for Dennis.
The Dennis. Yeah.
Didn't you put in the lithium charger, the 9160 AL?
Yep, I believe
Yep,
that's what it was. And so they're very happy with it. With that, I'm going to bring up Dennis and just give us an idea. You've got a good slide here on the charging cycle. Some of it, I look at it and kind of reminds me of chemistry in high school.
Well, thank you for the introduction, Dave. Welcome everyone watching the show. First, wanted to touch briefly on a little bit of history of chargers in an RV. They go way back, early versions. You took the battery with you, you connected it to your RV, and after your weekend, you took it home, put it on a charger, and used it the next time out. We added smaller units that allowed for a couple of AC outlets. You could plug it in somewhere, maybe plug something in the RV, and either work on the battery or use the charger to charge the battery. So when you got home, you could plug in at the house and charge your batteries. Gradually, the chargers, and these are all old style chargers, so big transformers, a lot of weight, and not very efficient, usually about 50%. So with the newer chargers, then you had two options. One was the 12 volt to run the RV. Usually those were a higher rating of maybe 30 to 50 amps for lights, fans, and other electronics in the RV, and usually 8 to 15 amps of battery charging, and with an option of maybe running strictly off the battery or charging the battery. At some point in time, after the military did some investigation, they came up with a power supply that was far more efficient, over 80%. Also much, much lighter, by using a method called pulse width modulation. What that does is take the raw AC power that you're sending, that you plug into your RV, and charger takes that, turns it into a DC voltage, feeds that to a transformer. There's a little chip inside the converter will take and pulse that transformer, and that's what gives you the output for the RV. You're usually operating at about 50 to 60 kilohertz, very, very high frequency. Gives us an advantage at the output of the charger. Requires a very small capacitor in relation to the early chargers, very small, higher frequency, less filtering that's needed. So as the charger is operating with a light load, you'll see on the top of the graph there, very narrow pulse width. So we send a pulse to the transformer, and that pulse gets processed out, rectified in the opposite end, and gives you a fixed voltage. Now, the whole principle of this operation is to maintain that fixed voltage on the output of the charger. You don't want the load to change and the voltage to drop off, or the load to be lightened and the voltage goes sky high. So if you increase the load, so the center picture, we have a medium load. As you notice here, the pulse width increased. So because we were trying to feed a heavy load, we were actually putting more power out through the transformer, through the filtering, to maintain that single level voltage. If we increase the load even up to maximum, these forward converters that we use have slightly less than 50% capability duty cycle. So this one's kind of showing 50 here, but it's actually slightly less. At full power, we're still maintaining that voltage and putting out the amperage needed to run the RV or charge the battery. So just to note, anytime you see a correct voltage on the output of the converter and your battery's not charging, there is a problem between the converter and the battery, not the converter. That converter is putting out the correct voltage. That current is available because anytime you put a load on it, we put more power out and to the rating, the maximum rating of the charger. That's basically how the charger works. So part of charging too is the differential voltage between the battery and the converter. You need a higher charging voltage than the battery voltage in order to allow current flow. Battery has internal resistance, wire has resistance. Those add up plus the current. The higher the differential, when you expand that out at say 14.4 in a boost charge, your charge rate is going to be much more rapid than it would be if you were in a normal charge rate of 13.6 volts or a storage charge rate of 13.2. In this example, this was a 100 amp hour battery, fully discharged. We basically got up to 90% in probably about 4 hours. It took probably about 30 hours to do that with a normal charge at 13.6 and well over 60 hours with just a slow, very slow charge at what we would consider a storage voltage. So that differential as you charge the battery gets smaller and smaller. And as you can see at the top of the curves, they don't increase in rate as rapidly as that first couple hours or first few minutes even. That's because the differential voltage between the battery and the converter is now lower. So the charge rate also becomes lower. There's less headroom to actually, for the battery to actually absorb the current. In general, it may take on a this particular battery 4 hours of boost and another 8 to 12 hours of normal charging to fully charge the battery. So we're looking at 12, 16, 18 hours to fully charge the battery. Now, this is a much slower rate than Fred was talking about with the batteries earlier, but we're also using slightly lower voltages. We do this for one purpose and one purpose primarily, and then that is for protection of your RV. We have a lot of electronics running in the RV. These chargers are running all the time. They are powering your RV. That's their first responsibility. Secondly, they charge your batteries. So we have to compromise. So we do have a boost voltage, 14.4, well within the operating voltages of the electronics in the RV, your control boards for your air conditioner, water heater, refrigerator, they all work safely at that voltage range. We start getting too much higher, then we run the risk of damaging those boards. So we have a compromise here. However, we can still effectively, a little longer, but fully charge those batteries, and that's what we want to do. We need to keep those batteries fully charged to keep sulfites from building up on the plates. If they build up on the plates and are lasting too long, you may or may not be able to get rid of them, and you lose capacity in the battery itself. So your 100 amp hour battery may become an 80, 60 amp capacity battery, amp hour capacity battery. So,
sorry to throw this in, Dennis, but your comment is these are two 6-volt batteries that just sat on a regular charger. They look like beach balls. So I just wanted to throw that picture in. Sorry to interrupt you.
That gets back to another part, and if you go back to the graph there, the previous, so we run about 30 to 33 hours in the normal mode to allow for the finished charging. Now, depending on the battery bank size, we may need to run longer. Like I said earlier on the particular battery in the previous slide, we needed another 8 to 12 hours, 8 to 16 hours, somewhere in that range. If there's light usage in the RV, then the Charge Wizard will drop down to a storage voltage of 13.2. It's still slightly higher than the 100% state of charge on a standard battery. It's enough to replenish any internal losses in the batteries. Batteries do have internal losses. If you put one on a shelf, it'll eventually bleed down. If you don't maintain that battery, you're going to destroy the battery. Eventually, you just won't be able to charge it anymore. The other thing we've added in our storage mode is a equalization mode. Now, this is not extremely high. There's been some question of people using this particular charger for lithium. We don't want 16 volts going to a lithium battery. The lithium battery will shut down. But at 14.4, we run for every 15 minutes. And that's basically just to get a refresh charge, help with destratification, and also help with some desulfation while you're in a long-term storage. Now, the batteries that Dave just showed us a minute ago, they were neglected. And unfortunately with the charger, if you have a dead battery, a bad battery, a shorted cell, the Charge Wizard, before you plug it in, is actually analyzing the voltage coming back from the battery. That battery voltage drops below a preset voltage, in our case below 11.9 volts. It's going to go into boost mode as soon as you plug in your Shoreline. With a battery that is defective, basically you're going to continue to destroy the battery. So you'll get gassing, severe gassing. You might set off your propane detector. You hear that one a lot. And generally it is a case of a shorted battery or a neglected battery. And believe me, it takes less than a week to neglect a battery and then throw full charge on it. Doesn't take long. I had a recent customer that went through 3 batteries until they realized they needed to leave the charger plugged in or the RV plugged in if they were going to run a lot of electronics in their RV. So during the storage mode, anytime you apply a charge voltage to the battery, there will be some gassing. The idea of the storage mode is to reduce the amount of gassing, but the big point here is you need to be able to maintain your batteries. Check your battery posts, keep them clean, make sure your water levels are good. If your water levels are low but above the plate, charge the battery, then fill them to a proper level. It's usually between 1/4 inch to 1/2 inch below the bottom of the well. If your water gets up above the bottom of the well and you're charging your battery, you may get some spitting from the taps. We don't want that either. It makes a mess. And of course, it's going to lead to the corrosion you see or the oxidation you see on the top of the battery posts. We don't want that. So in basic, that's the charging. Our Charge Wizards, in these particular models, the model that's on the left is a single stage charger. These are what came out originally. one voltage, 13.6 all the time. And people would leave their RV plugged in, and wouldn't be too long after a season or two, their batteries just were junk. They gassed out, they were overcharged for too long of a period. Lead acid batteries, the wet cells can be pretty rugged, but they can only take so much abuse. The charger that's shown on the right has a built-in charge wizard using the profile that was shown on the previous graph. Also, if you notice on the left-hand side, there's a little hole there. We have a pendant that plugs into that. If you could bring the pendant up, David. Thank you. Has two things on it. It's very, very simple. It's on a 50-inch cord. Has a button that allows you to change the charge mode, and also a light to indicate what charge mode you're in. So if you are in boost mode, you'll see a solid green light. Later versions also included a wink after 6 seconds and back to a solid light. The button allows you to change the mode. We find for most people, they don't need a charge wizard remote control. If they're plugged in all the time, the charge wizard does well to maintain the battery. Then again, if you're boondocking, have to fire up the generator. This allows you to put a rapid charge in the battery. The couple hours you may be allowed to run your generator at a campsite. And I've heard from some customers that some places they're down to an hour. So in order to optimize your generator run, again, that higher differential voltage, 14.4 on a battery that's at 12.2 is going to give you the optimum amount of current to put in that battery. You won't fully charge it, not in that amount of time, but you'll do much better than you would running your tow vehicle with the long wires and the limited current going to the battery and the lower voltage. So it's really the only time we recommend this. Some people like to have it just to say, oh, okay, things are working, and use it for just a guide to say, hey, I've got voltage anyways. Really, its only function as far as the LED is to tell you what mode the charger is in. Now, this still operates even though you remove shore power. The charge wizard in our chargers is in the output circuit of the charger itself. So that means it sees the battery voltage directly from the battery. So as long as that voltage is above 5 volts, standard operating voltage for the computer chip that runs the charge wizard, it will maintain function and monitor that battery voltage. Once that battery voltage drops below the threshold, it will trigger the converter to go into boost mode and continue to trigger that boost mode. And when you plug in, away you go. You're charging at 14.4. And that's a good indication. If you see that light up on you, that means your battery got below 50% because you're down now below 11.9 volts. And you should have already had your rig plugged in.
Okay. Dustin got some questions that came in.
Okay.
And I've got a few questions that came in specifically to the Progressive Dynamics. One thing we did get a question in is somebody's chair squeaking, and I think that is Dennis.
That's me. Yeah.
So if Dustin, if you could get some of your WD-40 and virtually spray his chair, we'll do that. But go ahead, Dustin. What do you got?
So basically, you know, we have two different types of customers that come into our shop. We've been in the same place for almost 20 years, and 50% of them are living in the units full time. The other 50% are weekend warriors. So for both of you guys, for Fred or Dennis, if you have an owner that, let's say, he's had the unit in storage for 2-3 months, battery's already, you know, obviously discharged a certain percentage, he's going to pick it up on a Wednesday night and take it home. I usually advise them to go ahead and plug it in the minute they get home, leave it plugged in for 24 hours. Then I'm usually telling them to go ahead and disconnect power from it and do like a discharge to the battery and then replug it back in before they go on a trip. Is there any advice that you would do to somebody that's, you know, what's your advice for if I'm going to go pick it up on Wednesday, what do I need to do before I go on my trip on Friday? if they're just going to go out to like a local campground and be plugged in?
From my point of view, the first thing I would see is inspect your battery,
Yep.
inspect the connections, check your water level. And if your battery is low, you're going to be charging at a high rate. Also monitor the battery case. That battery is starting to get hot. You either need to bring the voltage down or stop charging for a while, let the battery cool down. If everything seems to be normal, let the charger do what it's supposed to do. And I've kind of heard about the recommendation of letting the battery charge down or discharge and then recharging. That's probably good. I don't know if Fred, if you have anything to add to that.
Yeah, that can certainly help if you suspect that the battery may be sulfated if it's been sitting for a long time, particularly at a low state of charge. There are a couple of tools that can be used, to get a little bit better information. A simple digital voltmeter or multimeter can tell you a lot about the condition of the battery, and that'll tell you about how long it's going to take to recharge it. The other is a battery hydrometer. And on my slides there, I showed one that's very convenient. A typical automotive battery has lower concentration of acid or specific gravity. We recommend using a deep cycle battery hydrometer. And for anybody that has an Amazon account with Prime, you can have an EasyRed battery hydrometer sent to you. And this has a couple of nice features. First of all, if you check your specific gravity, it is dependent upon temperature, so you need to apply a correction factor to it, which takes a little bit of mathematics. Nice thing about the EasyRed is it does that for you. It's built in. There's a little disc that adjusts for temperature. So when you take a reading, you don't have to worry about compensating for temperature. The nice thing about that, you can check each individual cell. So if you see a cell starting to get weak, you'll see a lower specific gravity in that cell. There's also a good indication of when you need to equalize, because if you see a variation among the cells in one or more batteries, it's probably a good indication that it's time to equalize.
Yeah. The other question I had would be, most of the time we come across an owner that's, again, living in it full time. The unit's always plugged in. They never disconnect. They usually contact us, and it's at the point of, hey, I have no power. So their converter's burned up because their batteries are dried out. So they're usually having to get a new set of batteries as well as a converter. What I've been advising them to do is to, once a month, unplug the unit, check and make sure obviously the battery connections and the cables and the battery water level is full, but to unplug it, pretend like they're dry camping, for 4 hours or however long, depending on how many batteries they have, and then to plug the unit back in to kind of, exercise or cycle the batteries. Is that, good recommendations? I mean, as far as if you're living in it full time. And I know temperature changes, so I know that, summertime, obviously they're going to use more water burn off than in the winter, but is there any recommendations, that you have for that?
Yeah, obviously, if you're living in it full time, you're probably already exercising the batteries pretty well. And since we don't measure a battery life of deep cycle batteries in calendar life, we measure it in cycle life. Every cycle counts toward that maximum that you're going to get, which could be, anywhere from a few hundred cycles if you're using it all the way down to several thousand cycles. But still, every cycle counts. It's always good to use batteries. The biggest failure mode with lead acid batteries is lack of use, which typically is caused by lack of charging or charge maintenance. But it is healthy for batteries, if they're not being used heavily, to do an occasional discharge on purpose, just to make sure everything's working properly.
Okay. And the one last thing that I do see a lot, and I think, Dave, you probably see this as well, is owners will come in and, they've replaced the batteries in the past. And a lot of times the manufacturers, the OEMs, they'll use not a closed in terminal connection. So it's opened in. So a lot of times we're finding out that the battery cable itself is corroded or rotted back into the cable. So we're having to, replace the cable or shorten the cable to correct the connection because it's not charging the battery correctly.
That's very important. In fact, people that make cables, there's a lot of different techniques for doing that. The proper way is to use a swaging tool so that you're crimping 360 degrees around. If somebody makes them up at home, they're just going to hammer them down from one direction. and that's not going to make a good connection.
It-
I always like to solder
like
the
a
connections
soda.
as well because that will reduce the corrosion rate.
Well, and that's one of the things, just to jump in here, for those of you out watching this, the most important thing you can do is check your batteries, maintain them, clean them. I ask this question at my seminars often. I said, when was the last time you checked the water in your battery? And, most of the people, and there are a few, and a couple raise their hands, say, oh, you're the one. But they take them for granted because we have gotten into the mode of the car battery that you don't ever check it anymore. And there are people that don't check it at all. So the number one thing is check that level of your fluid. At least, some people do it every single time they go out. And I don't know if Fred, if your company has one of those quick fill devices, have you?
I was just going to lead into that. A lot of travel trailers and motorhomes have batteries in locations where they're really difficult, particularly have slide outs and so forth, to get to. So obviously you could put in sealed valve regulated lead acid batteries and not have to water them at all. Typically they're a little more expensive. A more cost-effective option is a single point watering system. Right. And we actually have a system, several different systems, but one of them actually has an electronic indicator that you can put wherever you want to. You could put it on the dashboard of the vehicle, and it actually gives you an indication of when the batteries need to be watered. Because don't fall into the trap. It's considered we call it a single point watering system, not an automatic watering system. We've had some issues where people didn't water the batteries, and when we said, well, why are your batteries dry? You have a watering system. They said, well, it's automatic. You still have to put water in the system, and you still have to initiate the watering cycle.
And distilled water. Let's
should be, yes.
Yeah. Well, and because the thing is, with your system, you take the existing caps out and you put individual caps with a check valve in it that has a hose, and you put that hose in. I've done that at my seminars. I've got a picture of it, in fact, on another PowerPoint. And before you take off on your trip, you just bring the distilled water over, put the hose in it. You hit the bulb squeeze until it doesn't fill anymore, and then every single one of those are done. So if it's way back in a compartment or somewhere, but to follow up on the maintenance, and the other thing that's so important to do is to check those terminals, make sure they're tight, make sure they're not corroded. These here, it's a little hard to see, but these are so corroded that I don't know how you're going to get any power out of it. So we're running a little fast here. I do have a question. You see it up on the screen. It comes from Kate or Kat. It says, will you talk about own-in generators? We have a diesel generator that actually has been sitting for a year with some fuel left in it. What should we do first? And I do have a picture of a generator. I guess just Dustin, if you want to touch on this briefly, this is not really into the battery topic side, but what do you see in generators?
If Cat basically goes to whether it be Onan or Seafoam, there's some real good videos on what to do if the generator's been sitting for a long period of time. There's different products out there that we use that we recommend to customers too, with Seafoam, and then the other one is Startron. And Startron has a enzyme in it that actually will reverse bad fuel into new fuel. Yeah. And it also makes the fuel stable for 2 years. Yeah. So using Startron, and then running the generator monthly, putting it under a load. Yeah. It's typically nowadays you can't even hardly rebuild those carburetors. They're not selling the kits anymore. A lot of them. Yeah. In most cases, they want you to buy a new carburetor. Yeah. So, and
hers is a diesel, she did say, so it's not as vulnerable to varnishing as the gas is, but it's still very important that you run it once a month to lubricate the seals and all the stuff in there. And what we found in a lot of the diesel generators, that if you don't run it under load, it's going to start to carbon up. Yeah. And it'll run, it'll start and everything, but it'll blow black smoke for an hour and a half. It seems like. So those are important things to do. So we got another question that came in here from Jeff. It says, I've always felt that load testing a battery was the best way to determine the health of a battery along with specific gravity. So I guess, Fred, with that, do you want to address that one?
Yeah, and that's an interesting question, because when you go out to buy a battery tester, It's probably not going to be a true load tester. It's probably going to be measuring internal resistance, which is what I alluded to earlier. Those are really intended for SLI batteries. But a true load tester will actually put a discharge on the battery. And we have on our data sheets, we have ratings all the way from the 20-hour rate up to the half-hour rate. So depending on what the discharge rate on your load tester, you actually have a rating for every discharge rate that you would need.
Yeah.
So that's right on our data sheets.
That's what a lot of people don't realize. They take their batteries into a battery shop or even a dealership, and they put on this tester, and they say, "Oh yeah, your battery's good. It's a 12.6 and it's good." Well, you can't tell sulfation with most of those unless you put it on, like you said, a load range, and that's where you get into problems with people thinking that my battery's good. I know it is, and they go out and they try something, and boom, it dies right away.
Yeah, it's hard to take the place of an actual discharge.
Yeah.
So even we check batteries all three ways, but we have a load tester or analyzer that analyzes a 6-volt battery. And one of the questions that you brought up was like how to bring the cold cranking amps into it, even though it's not a starting battery.
Right.
So when we do that on our analyzer, it tests the battery as a brand new battery, as a failed battery. So we still have to load test them regardless.
Yeah. And it's important to understand that there are failure modes of deep cycle batteries that can fail open. They'll show a good voltage, but if you try to discharge it, the voltage crashes to zero. So internal resistance testers won't always catch that.
Yeah. I'd say probably 3 out of 10 units that come in here when we test batteries a lot of times for free. 3 out of 10 units, bad batteries every single time.
Yep. That's pretty common. So here's a question for Dennis. It's specifically 2020 Jayco that's got a Progressive Dynamics PD9260C series. It says from what they found online that it has 4 modes: boost, normal, storage, and equalize. They have a 30 amp service in their motorhome, and they plug it in between trips to a 20 amp receptacle. I'm assuming on their house. And one of the things that I urge people to do is get a dedicated outlet at your house if you're going to plug your RV in before you go on to storage, because most of the outlets in your garage are going to be ganged to other outlets inside. Yeah. Very seldom do you have just one. So you could have a refrigerator, a freezer, an air compressor. You plug your rig in and people say, well, I'm just cooling down my refrigerator, which is only going to draw this. No, your charger's going to kick in. So her question is that if she uses an adapter to reduce 30 to 20, and she plugs it in, the unit's fully charged batteries, and then switch to those modes, and we'll do battery maintenance and sulfation. And her second question is, when she has that plugged in, does she have to have her main power switch on for the converter charger to perform that charging system? And if you would also just touch on that 20 amp, getting enough power to your RV, Dennis.
Okay, well, Dave, I need to agree with you on having a dedicated circuit at the house. There's too many other things, and there's also other things in the RV that may be taking AC power as well as the charger. If you have an extremely low battery, you're running in boost mode and pulling all the current out of the battery, and a 60 amp charger, you'll be pulling about 1,000 watts from the house. So 20 amp circuit, you're taking kind of about half your power, and it's limited to what it leaves for the rest of the RV. Lithium batteries, you're definitely going to pull a high rate out. After the charging is completed, this will drop down to the storage maintenance mode and perform the sulfation every 21 hours for that 15-minute period. As far as needing a 20 amp receptacle, it really depends on the charger you have. Any charger you have rated over 70 amps, you should have a 20 amp hookup. The 60 amp and 70 amp chargers or below will operate on a 15 amp circuit. Again, if you're on a 15 amp circuit, that means there's other things in the RV. You're not going to run your air conditioner, and you're not going to do that on 15 amps anyways. You're not going to want to run a water heater or even make a pot of coffee until your charging is complete. And I agree with one of the earlier comments too, is when you get back from your excursion, Plug in at the house, get that battery fully charged before you go into storage.
Yeah.
You have the time, you need to clean out the RV anyways, remove the food that you don't want to leave at a storage facility, clean up and get the sand out and all that good stuff. So plug it in, let the battery become fully charged before you go to your storage facility. Even if you're plugged in at the storage facility, after that 33 hour period, it will go into the storage mode. One thing people have to keep in mind, the storage mode is actually very effective. However, if you have power interruptions at your storage facility or even at home, you may end up losing charge on the battery. And if the batteries get too low, you may end up destroying the battery when you go back and charge them, charging at a high rate. Charger doesn't know you had a power outage. It has no way of knowing that. So keep in mind that, yes, this will do and maintain the battery, but it's also dependent on having steady commercial power while you're plugged in.
Yep.
Yes.
So we got Alan just
circuit is probably ideal for most situations. It does allow you to maybe run a few things in the RV while you're cleaning up, unloading, and so forth.
Okay, the next one we got Alan to ask, can you talk about voltage levels and what voltage I need to be aware of when approaching 50%?
So that would be on the DC side, obviously.
Yep.
Typically on a 12-volt system, if you have a low voltage cutoff that will terminate discharge automatically. Typically, you want, obviously depends on the magnitude of the load. But typically, at about 50%, you'll be right around 11.5 volts on a 12-volt system. A full discharge would be 10.5 volts.
Yeah, and one thing about 10.5 is that most of your appliances inside are going to have 10.5 to operate on the LP. I know the furnace, the gas valve, and the spark will not light if it's below 10 point, I think maybe even 7. The fan will still run, so it's a little deceiving that people think it's working, but just the fan running, blowing cold air in it. And so, but the next question we have, then let me pull up here, and we had that one. So what RV batteries do you recommend for the chassis and house? My rig is sat in dry storage for 2 years, and after a jump, it doesn't seem to be charging. Do any Group 24 batteries work for the chassis and any Group 31 work for the house?
So there's where we were talking about whether you have a pure deep cycle battery designed for deep cycle applications, and there are 24, 27, and Group 31 12-volt batteries designed specifically for deep cycle. There are SLI batteries in those group sizes that are only SLI batteries. If you put them into a deep cycle application, you might get 25 cycles out of it before you have to buy a new one. So obviously you don't want to use SLI batteries for deep cycle service. And then in between those two, there are hybrids, which marry up the biggest advantages of both SLI batteries and deep cycle. And they're usually good for 200 to 300 cycles in mixed service, but both engine start and for moderate deep cycle service. If you have an application that's not going to see a lot of cycles, that's probably a good choice. It's going to be a little less expensive than a true deep cycle battery. But if you have a heavy duty application, you're going to be money ahead if you get a true deep cycle battery. Yeah.
Well, let me throw this to Dustin too, because Dustin, you carry the Interstate brand and you've had success with that. And if it just Group 24, Group 27, Group 31, non-quality batteries are going to have the same classifications. Yeah. What do you see when people bring stuff in that they say they can get it at the membership box store for $89.95 and yours are $169? Why don't you address that?
So basically it goes back to the weight of the battery. So what we did was we actually took those box store batteries and weighed them to see what they actually came in at. And in some cases they were coming in at like 49 pounds, where the Interstate, the GC2 battery was coming in at like 68 to 69 pounds. So you're talking 20 pounds more of lead. And as Fred talked about, a true battery, I didn't even know that they made a 6-volt that was up as high as 200 pounds. But the weight in the battery is what I usually talk about when I'm recommending why go to that box store and pay $69 less, where you're going to get less life out of the battery. And then on this case, I've worked on a number of Fleetwood Discoveries, and so basically, like if that owner wanted to take the Group 24s, the 6-volt's the same footprint size of a Group 24. I think it's 2 inches taller. So if they have the shelf space or the cabinet space, or if it's underneath the steps, it would behoove them to upgrade from the 224s to 2 6-volts. And I'm usually giving them a layman's term of, hey, you're going to get, 5 to 5.5 times the battery strength of 2 6-volt or of 2 Group 24s.
And it's important also to recognize that there is a cycle life improvement going from 12-volt batteries to 6-volt. And that's basically due to the construction. Typically, a 12-volt battery is going to have thinner electrodes because it is going to see some engine start applications, whereas a true 6-volt golf cart battery is going to have the thick plates, the glass separators, and so forth.
In our showroom, we actually took a 6-volt deep cycle battery and we cut the top of it off after we cleaned it and basically killed the acid in it so that owners can see what the inside of the plates look like,
right,
and why it's important to keep the cells full. So, again, you were talking about owners making sure that they're doing the maintenance, checking the cables, checking the water level, checking the corrosion in the cables, cycling the batteries, plugging them in, discharging them. All that stuff's really key, because I think Dave off camera asked me, hey, what are some of the things that are ran off a 12-volt? Nowadays, what's not? Everything ran. And as technology is increasing, all the touchscreen stuff, it's all 12-volt.
I think what's really important to add to Dustin's comment about that is that as an owner, you really need to educate yourself on what components run on 12-volt. Not just the lights and the vents. I had a question come in and somebody said, well, when I'm not plugged into Shoreline Power, all my lights work inside, but none of my outlets do. That's like, okay, 12-volt versus 120 AC. And people expect to walk out of their house and just be able to flip a switch like they do at home. And so, you as owners really need to educate on what runs at 12-volt. An AC unit, the control module runs off a 12-volt. On the refrigerator, the eyebrow board and the thermistor run off a 12-volt. All that stuff is important. I do have one more question here. We're getting almost out of time here, but this one is a good one for Dennis and Fred, that we're seeing more and more people doing solar panels now and boondocking. So this person has a 30-amp system with a converter charger, also solar panels on the roof. Can the solar panels overcharge the batteries if I plugged into Shoreline Power and they're both working?
That's kind of a yes and no. Number one, if you're using solar, you do need a solar controller. It's going to take that high voltage from the solar panel, bring it down to a usable level for the battery charging. You'll find that most of the solar manufacturers have their own controllers. There's also other market controllers that you can use with the solar panels. Solar panels need to be at least 5 volts higher than what's being provided to the battery. And usually they have multiple profile settings that should be geared towards your individual battery type. And as long as you're doing that, that's okay. If you have solar operating and you plug in one of our converters, more than likely it's going to start up in the normal mode at 13.6. And so it may aid the solar panel. It really depends on what mode in the profile that the solar panel's in. But then again, after a period of time, our charger will drop down to a storage voltage. So usually what we see is people in the morning, those solar panels will power up, charge at a high rate, and then drop down lower. Running 13.6 every once in a while, it shouldn't hurt the battery. And you do want to maintain those batteries. So it shouldn't be a problem.
Well,
and you said the right thing, Dennis. That the important thing there is the charge controller. So regardless of what size your panels are and what voltage they're set at, the charge controller should handle all that. You do have a natural charge control, and that's called when the sun goes down, charging stops. So it's very unlikely that you're going to overcharge property-sized batteries strictly using solar.
In
Most
Iowa,
people
we call
also
that
use-
winter.
Yeah. Well,
We have,
then-
we have 6 months of automatic shutdown. But
Exactly.
that brings up a good point on the solar panels too, just like the batteries, a quality solar panel. There's a lot of products out in the market that are creeping into the RV industry that were made for residential type solar and battery power and things that just don't hold up to the rigors of what the RV is going to be put through, the temperature changes and the bouncing down the road. And the cheap solar panels that you find in these discount stores, I know a box store that I can go to and I can find a 100-watt solar panel for $69.95 or $79.95, and it doesn't have the right crystals. It's soldered instead of mechanically connected, and all that stuff just translates into something that's not going to work. And if it doesn't have a charge controller, that's a good point, Dennis.
It's important to point out there are solar battery chargers that have built-in charge control set up for 12 volts.
Yeah, and I'm just going to throw
that's an excellent way to maintain your batteries, by the way, when you're not using them.
Yeah, I'm just going to throw out a couple companies that we've worked with extensively: Zamp Solar and Go Power. They are both owned by Dometic now, but both of those companies have really dedicated themselves to building a quality product and working on that stuff. And we've put them on several units, and I am very, very impressed with their approach to it and their product with it. And they work with the RV companies too. That's a big one. So one more question I think we have. We're right at 7:00. I just want to say that there's a person says, I noticed my house batteries do not seem to be charging when I'm plugged in, and that they replaced them in the spring, and was wondering if the inverter converter goes bad. And maybe you can just touch on, how do you tell what kind of charger you have? Use a multimeter to see the different voltages, and what are the things to look for if that happens?
Okay, well, the caller mentioned inverter charger. Those are available. The inverter is actually also, when you're on shore power, will provide charging for the battery. So reading the output voltage or the DC side of the inverter when you're on shore mode with a voltmeter, you should see voltages of probably 13.6 or higher, depending on how the inverter is set up. And then you should see that voltage at the battery. With an inverter charger, if that wasn't working, it may be a defective charger in the inverter or an open circuit. And of course, then the inverter would not work also on battery power. Critical to know the voltage at the charger and the voltage at the battery. If your charger is putting out voltage like I showed before, and you're seeing anywhere in our case from 13.2 to 14.4, you should be seeing voltages above 13 volts at the battery. Now that will depend on how much current is being drawn, how much wire loss and voltage drop between the battery and the converter, but generally you're going to see over 13 volts. And if you're not seeing that, and you're seeing a 12.5 volts or 10.5 volts, that charge voltage is not getting to the battery. That's when you need to check. Usually it's your battery protection device, short stop circuit breaker. Occasionally it may also be your disconnect switch, and also could be a bad connection anywhere between the converter and the battery.
Okay.
We often get the question, how do I know if I have a battery problem or a charger problem? On the U.S. Battery website is a charger diagnostic procedure that goes through a step-by-step process to make that determination.
And you know what? You have a user's manual that we were going to show, and let me bring that up here.
And Fred, I got to say, your website's really good. I visited it this afternoon, and there's a lot of good information for consumers.
We put a lot of work into it recently. That the user's manual is current, so it was completed recently.
Yeah. Now, to go back to the question real quick,
Right, there we go.
Most converters are going to have either a fuse or they're going to have a resettable circuit breaker on them. So if it's plugged in and it's not, if they're not experiencing any voltage in the coach, or if it's not charging the battery, check, because sometimes there is, more than one fuse or resettable circuit breaker that can easily be tripped and just need to be reset.
That's true.
Okay. So here's the website usbattery.com. The user manual in there is an outstanding manual, and that is the link to go directly to that site. One of the things, also, we had the lady with the Cat, I believe it was, with the diesel generator. She asked, she's already got fuel in the fuel tank. Is it okay to add the seafoam or the stabilizer afterwards? It is.
Yes.
I think that's a good thing to put in there. If we have some other questions, one of the things we're going to do after this will be recorded, and we're going to have a landing page. So if we have any questions that didn't get answered, we'll be able to go back in there and add those questions. This will be available to view on the website. And I think one last question that I had that came up from several people in here is that if you have batteries that are completely sulfated, like the ones that were in this one here, or don't even have batteries, and you're plugging in all the time, you can still run the 12-volt system. Dennis, I'm told that the converter will run at 13.6, but the downside of that is it's going to run all the time.
It's going to burn up the high side.
Yeah.
Well, and the converter will run all the time when you have AC power. That's the way it is. If you have bad batteries, and you need to run on converter power, disconnect the negative lead from the battery from the chassis. That takes the battery load off the charger, allows the charger full opportunity to run all the electronics in the RV. And you have to remember the RVs generally have a charger that is rated for operation to run without a battery. So we have 90 amp chargers and 60 amp chargers. That's usually based on the size of the RV, not per se what's needed for charging the battery.
Great. All right. Well, we're out of time. And Chuck just put up the Oscar nomination speech music that hit our time limit. We appreciate everybody coming out. I do see in the comments, Snoopy came in. He's one of my my biggest critics out there. I wouldn't say critics. He challenges me every day, and I appreciate your coming out. And I appreciate everybody that's joined us here. Tell your friends about it. We're going to do it again next week at the same time, and we are going to look at lithium batteries at that point. So we kept those out of this conversation just because that is a whole conversation on itself. And we've got Kat that says thank you and looking forward to these. Thank you, Kat. Appreciate it. And everybody that's been out there. And we really appreciate all you readers from rvtravel.com as well. Keep reading the articles. Keep sending in your questions and your comments. And Dennis, Fred, Dustin, thank you very much for joining us. We covered a lot of things, and hopefully people will have a chance to absorb it. And, the bottom line is try to extend the life of those batteries by just doing a little bit of maintenance and understanding, what you need to do to properly charge them.
Yeah. Travel safe and make sure you keep an eye on those batteries because they can catch on fire.
Mm-hmm. All right. So thanks, guys. Appreciate everybody coming out. One last comment says, thank you for very informative discussion from Kat. So see you next week, everybody.
Thanks, everyone.